In this episode, we're going to walk through the moment that makes even confident learners feel a little stuck. A Linux system that will not boot, or that starts to boot and then falls apart. Boot failures feel dramatic because you lose the normal tools you rely on, and the screen can show messages that look like a foreign language at first. The good news is that boot problems usually follow a small number of patterns, and you can learn to recognize them without memorizing obscure details. When you approach boot failures like a first responder, you focus on preserving evidence, reducing risk, and narrowing possibilities instead of guessing. We will spend time on two common categories that show up on Linux Plus style reasoning: bootloader issues, often connected to Grand Unified Bootloader, GRUB, configuration problems, and kernel-level failures such as a kernel panic. By the end, you should be able to describe what these failures mean, what likely caused them, and how to triage them methodically without turning a bad day into a worse one. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A strong triage mindset begins with recognizing that boot is not one step, but a chain of handoffs, and each handoff is a place where things can break. Power and firmware start the process, storage is discovered, a bootloader selects what to load, the kernel takes over, early user space prepares the system, and then the normal service startup begins. If you know where the failure occurred in that chain, you instantly reduce the number of plausible causes. A bootloader failure looks different from a kernel failure, and a kernel failure looks different from a user space failure, where services fail after the kernel is already running. Beginners often treat any boot issue as one big mystery, but experienced responders treat the boot screen as a timeline. The text you see is not random. It is evidence about which stage you reached. When you build the habit of asking what stage you are in, you stop flailing and start making controlled decisions that preserve the ability to recover. It also helps to understand what firmware is doing, because it shapes how the system finds the bootloader in the first place. On many systems, the firmware is Unified Extensible Firmware Interface, UEFI, while older systems may rely on Basic Input-Output System, BIOS. You do not need to be an expert in firmware to triage boot failures, but you do need to know that the firmware decides which disk to try, where to look for boot information, and what order to attempt boot devices. If the system suddenly fails after a hardware change, a storage change, or a firmware update, the failure may occur before Linux is even involved, because the firmware might be pointing at the wrong device or might not be able to read the boot configuration. This is why first response triage begins with minimal assumptions. You do not jump straight to reinstalling anything. You first determine whether the firmware is consistently reaching the bootloader stage, because that confirms storage discovery and basic boot selection are still working. Once the system reaches the bootloader, GRUB becomes a major actor in the story, because it is responsible for presenting boot choices and loading the kernel and supporting components. A bootloader misconfiguration often means GRUB is looking for the wrong kernel, the wrong file system location, or the wrong identifiers for the disk and partitions. One reason this category is so common is that storage identifiers can change in ways that confuse configuration, especially after disk replacement, partition resizing, cloning, or changes to how storage is presented. Another reason is that administrators sometimes modify boot settings to troubleshoot performance or hardware compatibility, and a small mistake can make the next boot fail. From a triage perspective, the key is to recognize symptoms. If the system never reaches the kernel stage and instead loops, complains about missing files, or cannot find a boot target, you are likely still in the bootloader phase. That tells you to focus on boot configuration integrity rather than on services or applications. GRUB failures also illustrate why safe undo thinking matters in operations, because the bootloader is a fragile boundary where a small configuration error can block the entire system. A common beginner misunderstanding is to assume that if a system fails to boot, the operating system must be corrupted. In reality, the operating system can be perfectly intact while the bootloader simply cannot locate the correct kernel or the correct root file system. In those cases, The best response is not dramatic repair, but careful verification of what GRUB believes the system layout is. Another misunderstanding is to treat the boot menu as just cosmetic when it is actually a diagnostic interface. The entries, the selection behavior, and even whether the menu appears can hint at what was recently changed. In triage, your goal is to preserve optionality, meaning you want to avoid changes that destroy information, and you want to identify whether a known good boot option exists before you attempt more invasive recovery steps. A useful way to think about the kernel stage is that it is the moment Linux starts being Linux, and failures here tend to be more fundamental than a missing service after boot. When the kernel loads, it must initialize hardware access, memory management, and the file system path that will become the root of the running system. If something essential is missing or inconsistent, the kernel may stop with a kernel panic, which is a protective halt that says the system cannot continue safely. Kernel panics can feel terrifying because they are loud and definitive, but they are also informative because they usually happen at a specific moment in the boot timeline and often relate to a specific class of problem. A beginner might think a panic means the machine is permanently broken, but many panics are caused by configuration mismatches, driver issues, or incorrect root file system references after changes. The triage goal is to interpret the panic as a symptom of a mismatch between what the kernel expects and what the environment provides, rather than as a mysterious curse. One of the most common conceptual causes of a kernel panic during boot is that the kernel cannot mount the root file system it was told to mount. This might happen if the root partition identifier changed, if a file system is damaged, or if the drivers needed to access the storage are not available early enough. That early timing detail matters, because storage drivers might normally load later during a full boot, but the kernel needs access to the root file system immediately to proceed. This is why many systems rely on an initial RAM file system, which is a small, early environment that contains drivers and tools needed before the full root file system is available. The commonly referenced component is Initial RAM File System, INIT or AMFS, and it acts like a bridge between the kernel and the full operating system. If that bridge is missing the right components, the kernel may be unable to reach the root file system even though the disk itself is fine. A triage mindset considers this bridge conceptually because it explains why a system can fail even when storage looks physically present. Kernel-related boot failures can also appear after updates or configuration changes that affect which kernel is selected. Many Linux systems keep more than one kernel available, so you can boot an older one if a new one causes issues. If a new kernel introduces a driver incompatibility, the system may panic or hang early, while an older kernel may boot normally. The educational point here is not to memorize specific kernel versions, but to understand why having a fallback kernel is part of operational resilience. Beginners sometimes believe updates are all or nothing, where a bad update bricks the system. But mature systems design includes rollback options precisely because kernel and driver interactions can be complex. In triage, the existence of multiple kernels is a clue that you should consider whether the failure began after a change and whether a previous known good boot path still exists. That approach reduces risk because you are using existing safety rails rather than introducing new variables during a stressful moment. First response triage also includes a discipline around observation, because the screen output during boot is often the only evidence you have before the system becomes usable. A calm responder pays attention to what the last successful message was, how far the boot process got, and whether the failure is consistent across reboots. Consistency is a powerful clue. A failure that happens in the exact same place suggests a deterministic configuration issue, while a failure that moves around suggests intermittent hardware issues or corruption. Another important habit is to notice whether the system reboots on its own, freezes, or drops into a limited recovery environment, because each behavior points to different categories of fault. You do not need to copy down every line, but you do need to form a picture of the stage and the pattern. This is the same mindset as reading logs later, except the boot screen is the log. When you treat it that way, you make fewer impulsive changes and you preserve the information needed for a clean fix. Bootloader problems and kernel problems often get confused because they both happen before the system feels fully alive, but the distinction is worth protecting in your mind. When GRUB is failing, The system typically has not successfully handed off control to the kernel, and the symptoms often involve missing boot targets or menu-level issues. When the kernel is failing, the kernel has taken control and is now halting because it cannot safely continue, and the symptoms often involve hardware initialization, file system mounting, or early environment setup. This distinction matters because the corrective thinking is different. Bootloader issues are usually about locating and loading the right components, while kernel issues are usually about compatibility and access to critical resources. Beginners sometimes jump from any boot failure straight to reinstalling, but reinstalling is a high-impact move that may hide the root cause and can introduce new risks. A better mental model is to first classify, then choose the least invasive recovery path that addresses the likely category, keeping your changes reversible whenever possible. Another important triage idea is to think about what changed, because boot failures are often introduced by change rather than by spontaneous collapse. Changes can include updates, new drivers, storage modifications, changes in firmware settings, or even shifts in how disks are enumerated after hardware adjustments. The skill is not to blame change, but to use it as a narrowing tool. If the system was booting yesterday and failed today after a planned change, the first hypothesis should be a mismatch introduced by that change. If the system failed without any known changes, you should widen the hypothesis space to include hardware degradation, file system issues, and unexpected power events. This is a classic operations reasoning pattern. Known recent change increases the likelihood of configuration error, while no known change increases the likelihood of environmental or hardware factors. For Linux Plus style thinking, the key is to articulate the logic behind your hypothesis, because that shows you are not guessing, you are making evidence-based inferences. A practical recovery mindset also includes understanding that boot issues can have layers, where the first visible failure is not the root cause, but a downstream effect. For example, a disk problem might cause a bootloader error because the bootloader cannot read a file, and that might look like a configuration mistake at first glance. Similarly, a file system inconsistency might cause the kernel to fail mounting the root file system, and that might look like a driver issue until you confirm the storage is readable. This is why first response triage should avoid irreversible actions that destroy evidence, such as wiping or reformatting, until you have strong confidence in the diagnosis. The safer habit is to think in terms of confirming or rejecting categories. You look for signals that confirm the disk is readable, that the bootloader can find its components, that the kernel loads, and that the early environment can reach the root file system. Each confirmation collapses uncertainty and reduces the risk of doing the wrong repair. It is also worth connecting boot triage to the broader security and reliability mindset you are building throughout Linux Plus. A boot failure is not only an availability problem, it can also have security implications if it tempts you into risky shortcuts. Under pressure, people sometimes disable protections, change settings they do not fully understand, or expose sensitive recovery interfaces in ways that increase long-term risk. A mature responder treats recovery as a controlled process with minimal exposure, especially on systems that hold sensitive data. Even when you are just learning, this mindset matters because it trains you to balance speed with safety. The system being down feels urgent, but a rushed recovery that weakens integrity can create a bigger incident later. The healthiest approach is to restore the system to a known good boot state using the least risky path, then investigate the underlying cause so it does not repeat. That investigative follow-up is part of triage too, because real recovery includes preventing recurrence. As we wrap up, the most valuable skill you can carry forward is the ability to map symptoms to the boot timeline and respond with calm, staged reasoning. Bootloader issues, including GRUB misconfiguration, are often about the system being unable to locate or load the right kernel and supporting files, even when the operating system data is still intact. Kernel panics are protective halts that usually signal an essential mismatch, such as failure to mount the root file system, missing early drivers, or incompatibilities introduced by updates or hardware changes, often involving how init or AMFS bridges early boot needs. First response triage is the disciplined practice of observing where the failure occurs, looking for consistency, considering recent changes, and choosing the least invasive recovery move that preserves evidence and reversibility. When you treat boot failures as solvable patterns rather than as chaos, you build confidence that extends beyond this topic because you are practicing the same methodical thinking that makes Linux administration reliable. That confidence, more than any single fix, is what turns a scary boot screen into a problem you can reason through.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.